Okay, we've talked about this before now. There are 3 different ways which you can call somebody a liar. Okay? One of the ways is if your p-value, the chances you got a sample mean that far away, is lower than your risk threshold. We get a p-value of 3% and that's lower than the 5%, we'll call a person a liar. There's only a 3% chance of getting an x-bar like that. The other way is just look at the z-scores. Is my z-score bigger than where I needed to get to prove them wrong? And the third way we've talked about before. You go create a confidence interval. Hey, what you said is true is not in my confidence interval. You're wrong. Or, hey, what you said is in my confidence interval. Well, I can't prove you wrong with that. So we look at our confidence interval and see if what they said was true is in it or not. Now here's the trick. You've got to figure out which percent confidence interval goes with the problem they're prescribing. Let me show you what I mean. This is kind of similar to what we were just talking about. Let's say we've got an alternate hypothesis that mu is not equal to something. And we've got an alpha level of 5%. Okay. What percentage are going to be in our rejection regions in this situation? 2.5%, right? Now understand what this means. Here's the true mean. This is the margin of error. If my x-bar gets out here and I go my margin of error, I'm not going to have your mean in my confidence interval. But if my x-bar is in here and I go my margin of error, then what you said is true is in my confidence interval. So here's the question. Based on this situation, when I've got a 5% alpha and it's two-sided, what kind of a confidence interval would I need to do? This picture corresponds to what percent confidence interval? The 95% confidence interval, right? A 95% confidence interval is going to have the 2.5% in the tails. And that's my trick for you. Go look at what's in the tails and then tell me which confidence interval that corresponds to. All right, let me get a little trickier. It's a one-sided test. So I'm all my 5%, the most extreme 5% on that side, I'm going to reject. So I've found my percentage in the tail. What kind of a confidence interval? What percent confidence interval has 5% in a tail? The 90, right? It'll have 5% in the other tail. So this would be a 90% confidence interval. So if you want to figure out whether you'd reject this situation or not, you got to know what percent confidence interval matches this problem. Okay. I don't know. I can't get much more tricky than that. The alternate, not equal to alpha 1%. What percent confidence interval corresponds with a two-sided alternate hypothesis and a 1% alpha? Now, I want you to draw these pictures. When you're given this kind of a problem in this situation, draw the picture and go find out what percent we have in the tail. In this particular problem, what are we going to have? And this is two-sided, so what are we going to have in our two tails? 0.005. What percent confidence interval has 0.005 in the tails? The 99%. Okay? So that's how you can match up which confidence interval goes with the particular test that you're trying to figure out. Okay? All right, a lot of people in here. Yeah.
That only works for when it's two-sided, right?
No. Yeah, the 99%. If this was one-sided, then I would have all 1% over here. So what percent confidence interval has 1% in a tail? The 98. You'd have 1% on both sides. Okay. All right, a lot of you have asked these questions as we've gone along. How do you set this thing? We've talked about 1%, 5%, 10%. Which one do you pick? And those aren't the only ones. You could do 0.5% or 8%. How do you figure out what to set your threshold of making a mistake would be? Okay, how do you know when you've got enough proof? All right, just a couple of things for you to consider. Item 1. How hard is it for you to convince somebody that you've proven them wrong? How hard is that going to be? For example, let's say my null hypothesis is the sky is blue. Is it going to be hard for me to prove to you that the sky is not really blue? Is that going to be a tough sell? Is that going to be difficult? Then I better be darn sure. I better have some tremendous proof. Where would you set that alpha level if you were trying to prove something to somebody that they think they know the answer to? You set your alpha level at? Like 1%. Yeah, you better be coming bringing some heat. Maybe you know, I'd set that so hey, my p-value is like 0.00001. And what do we need? Okay. Now, if the null hypothesis is something that's kind of, you know, manti-tail, what did he do it? Did he not do it? Nobody knows, right? Nobody knows. 4 years from now, they're going to be listening to this. Who's manti-tail? Anyway, if the null hypothesis is kind of, you don't know, you may not need as much proof to prove somebody. You can set your alpha level a little higher. Is that our bell? Rejecting. The consequences of rejecting. So in other words, if you put this pill on the market and people die, you better be darn well sure you've got the right answer. So you'd set your alpha level at 1%. You're not going to put that pill on the market otherwise. Other times, guys, you just don't even put an alpha level. If you don't have to make a decision, just give them the p-value and let them make the decision. Like if you give them a p-value of 5.1% or 4.9%, there's not that big of a difference. Let them make the decision. Your homework tonight.